Thank you. So far we are discussing about synchronous counter and ripple counter. Okay, and I told you in ripple counter, okay, the time periods of clock should be greater than your propagation delay of one flip-flop. Okay, so that is your TPD is basically propagation delay. We already discussed delay of one flip-flop. Okay, now in the case of synchronous counter, okay, so when this is TC should be greater than n TPD, so automatically we have seen there is a limit on frequency F max for the ripple counter, which is equals to 1 TPD. Okay, now if I talk about the synchronous counter, okay, synchronous counter, as they triggered simultaneously, okay, so that delay do not get add. So we have the clock condition, the clock should be, time period should be greater than TPD of one flip-flop plus this is a flip-flop propagation delay and the propagation delay for one AND gate. Okay, so this is the basically formula for if I want to write the F max for a synchronous counter. Okay, so to remember this formula is propagation delay of one flip-flop plus propagation delay of AND gate. Okay, so this is a fixed. Now whether you have a 3-bit counter, 4-bit counter, any bit counter, this will not change. This will not change. This frequency will not change with increasing the counters. Okay, just give me 1 minute. Okay. So, for example, if one problem we'll see. So a question is given. It says compare the F max. Okay. Compare the F max. Okay. For a 4-bit of a 4-bit ripple counter. Okay, you have a 4-bit ripple counter. And you have a 4-bit synchronous counter. 4-bit synchronous counter. And they have given you the TPD for flip-flop. TPD for flip-flop is equal to 50 nanoseconds for one flip-flop, and TPD for AND gate they have given you 20 nanoseconds for one flip-flop. Okay, so now they're asking the F max for both the counters. Okay, so if you want to calculate F max, formula just now I have written. Okay, so for ripple counter, you have F max equals to 1 upon n TPD. Okay, so now 4-bit ripple counter require 4 flip-flop. This will be 4 into 15 nanosecond. This 10 to the power minus 9. Okay, so this become what? 10 to the power 1, 10 to the power 8 to 10 to the power 8 upon 20. How much? 20, or it become 10 to the power 7 upon 2. Okay, so 10, so 5 into 10 to the power 6. Okay, 5 megahertz for ripple counter. And similarly, if I calculate the F max for synchronous counter, the F max will be now 1 upon n TPD. So Now only one TPD you to take. Okay, so 50 nanosecond plus 20 nanosecond. Okay, so 70 nanosecond, 10 to the power 9 upon 70 nanoseconds. Okay, so if you solve this one, this should give you how much? 14.3 megahertz. If you solve this one, okay, this is giving 14.3 megahertz. 14.3 megahertz. So you can see the same counters. They have 4-bit counter we are comparing. Okay, so and if you know the delay of flip-flop, so 4-bit counter has a better frequency, maximum frequency is higher. That means it can count faster than your ripple counter. Now suppose same counter, same ripple counter and we have this synchronous counter. Instead of now we have 5-bit ripple counter. Just now we calculated for 4-bit. Now suppose it is 5-bit counters. So we see now here instead of 4 there will be 5. Okay, and if you calculate now in this case the frequency, okay, so this will, if you solve this one now for 5-bit, so this how much become 10 to the power 8, okay, and 25, so this become 4 megahertz. Okay, because 10 is 4 into 10 to the power 6, so become 4 megahertz. So as the number of bit increases, ripple counter becomes more and more slower. Okay, it gets slower. So the maximum frequency is only 4 megahertz. Earlier it was 5. Okay, so if you keep on adding the flip flop, the maximum frequency will decrease. While it is here, it is constant. Okay, so if whether you take 4-bit counter, 3-bit counter, 5-bit counter, 6-bit counter, 8-bit counter, the f max is for synchronous counter is remains the same. So that is the advantage. Okay, synchronous counter have compared to ripple counter, their frequency is high, so they can count faster. So this was the one of the difference between synchronous counter and counter. Okay, now there are two small counter remaining. Okay, one is called ring counter and twisted ring counter. Okay, so ring counter is basically your shift register counter. Shift register counter. Okay, this is also called mod n counter. Mod n counter. Okay, that is, it has a n states. N states. So n, it has a n flip flop. Okay, so and n states. Okay, so for example, now what is the construction of design of ring counter? Why we call it a ring counter? Because it is like a ring. It will keep on counting the states depending on the initial state. So they have, say, I'm taking 4-bit counter, 4-bit ring counter. So I have four flip flops. Okay, and say take it as a D flip flop. So say this is Q1. Okay, this is Q2, this is Q3, this is Q4. Okay, so they all are synchronous counter. Synchronous counter. So they have a same clock. They have same clock. Okay. Now here, why this is called ring counter? Because the input of output of one flip flop becomes input for other. So like it's like a shift, like we have done the case of shift register. Okay, these were connected. So these are connected, and the ring counter because the last one is connected to the first one. Last one is connected to the first one. Okay. Now this is counter is called mod and counter. Okay. Mod and counter it is the end state. So for flip flop, this counter will have 4 different states. Okay. But you have to remember, you can't put all 0 0 or one initial condition. Okay. So generally out of this 4 flip flop, there is only one Q is 1. Okay. Other remains 0. Okay. So for example, if I say the initial condition is 1 0 0. Okay, say this initial condition is 1 0 0. Initial condition 1 0 0. Okay, that means this is your Q4, Q3, Q2, Q1. Okay, so this is your 1. Initial condition, this is 0 0 0 0. Okay, so this is the output of this is the input for first one. Okay, now like a shift register, this one will shift. Okay, and different states will form. So for example, if I give the clock, so say, let us say now I have a table Q3, Q4, Q3, Q2, and I have a Q1, and we have a clock. Okay, so in the beginning, the condition is 1 1 0 0. We have to give initial condition, and most cases we give only 1 1. Okay, now first clock will come. The first clock will see the input of this one is 1. So this is automatically set condition. So this become 1. So your Q1 will become 1. Q1 will become 1. Okay. Q2 becomes 0. Q3 becomes 0. Okay. And Q4 also becomes 0. But this is 1. Q1 become 1. This become this here, this becomes 0. This 0 come here, becomes 0. This come here, this becomes 0. Okay. So now suppose second clock comes. Okay, so second clock, you have to remember now what are the outputs. Okay, so for second clock we already said sold Q4 is the Q4 is the input for 1. This is 0. So okay, and Q3 is 0, Q2 0. So Q4 input is 0. Okay, so this becomes 0. Similarly sorry, Q4 Q3 is 0, so 0. Okay, Q2 is 0, so Q3 is also 0. Q2 is Q1 is 1. Okay, so this becomes 1, this becomes 0. Q1 becomes 0. Okay, because Q4 was 0. Now if you take clock third, okay, so clock third, so Q1 input is your Q1 input is this one here, Q4, which is 0. So this remains 0. Okay, Q2 input is Q1, which was 0. So this becomes 0. Okay, now this is Q3 input was Q2, which is 1. Okay, so this becomes 1. Similarly, Q4 input is Q3, which was 0 here. So this becomes 0 here. Okay, so this one is keep on shifting. Okay, if you don't understand, you can make Q1 go to Q3 Q4, then that you can understand better. Now fourth, okay, now in the fourth clock we have to see what is the input here, what is the output of Q4. So Q4 was 0, so the automatic display 0. Okay, Q1 input was 0, so the 0. Now Q2 input is Q1, so Q1 was initially 0, so it becomes 0. Okay, and then Q3 input was Q2 0, so it was 0. And this is your what, this is 1. So Q4 input was Q3, that's 1, it has become 1. Okay, so this is your fourth state. So you see, we start from here. Okay, 1 2 3 4, again repeating. So this is this ring counter has only 4 end states. Okay, so this is a 4 flip flop. Okay, 1 2 3. So it is only 4 state. Now this after 1 0 0, again 0 0 0 1 come. So this states will be keep on changing. Okay, so this is 0. So the states, if you plot a state diagram, you have 1 0 0, then you have a 0 0 0 1, then you have what, then you have a 0 0 1 0 0 0 1 0, then you have a 0 1 0 0 0 1 0 0, and then again you're coming to 1 0 0. So it has only 4 state. Okay, so this is the state diagram for ring counter, 4-bit state counter. So state depends what are the initial condition. Okay, state depends what is the initial condition, accordingly they'll form different state, but the count of the state will be only 4. Okay, so this is your ring counter. We can count only n state, which is also called mod n counter. Now we'll see twisted ring counter. Okay, twisted ring counter, which has called mod 2n counter. Okay, and flip flop and 2n states. Okay, so mod twisted ring counter is slightly different than ring counter. Okay, so they have also like a shift register kind of connection. Input of one is other, output of other. Instead of this one here, last input, if instead of taking this Q4, I will take Q4 bar. If we have a Q3 bar here, we have Q2 bar here, and we have Q1 bar here. So instead of taking Q4, this time I will take Q4 bar. Okay, so this will become your twisted ring counter. Okay, so this is basically your twisted ring counter. Okay, so let me make a little bit smaller, so I need more space. So I'm drawing this again. Okay, so we have a flip flop 1 2 3 4 clock. This is clock. Okay, now we have this Q1 bar, Q2 bar, Q3 bar, Q4 bar. Okay, now suppose I'm giving the states to this counter. So initial condition is 0 0, initially 0 0 0. Okay, now I have Q4, Q1, Q2, Q3. Now here, not necessarily which is MSB, which LSB. Okay, that depends. Okay, what we're trying to do. So just not necessarily I am making. Okay, so I can make the table Q1, Q2 also, just to understand. So here this I have not shown this is MSB or this is LSB. That is different. Okay, so let me draw like Q1, Q2, Q4. So if the question tells this is MSB, then you would draw like, otherwise I'm drawing like this. Okay, so we have a clock here. Okay, and this clock has, say, initial condition 0 0 0. Okay, so this makes a little bit slighter easier for me to make the clock. Okay, now suppose clock 1 is coming. So Q4 is 0, that is Q4 bar is 1. So for initial clock, this is 1, this is 0, this is 0, this is 0. Okay, so I know what is the input of this one is 1. So this become 1 here. Clock 1 this become 1. Input of this was 0. Input 1 is 0. So input 1 this was 0. So it becomes 0. Q4 0. Okay. Again, if second pulse comes, okay, Q1 input is 1 because it is 0. So Q4 is 1. So again it is 1. Okay. So this become 1. Okay. Q2 input is Q1. So 1. Q3 input is 0. So 0. Q4 input is 0. So 0. Okay. Now let me write for clock third. Again, it is Q bar 1. So 1 will come here, this 1 come here, this 1 come here, this 0 comes here. For fourth clock, again this 1's come here, this 1 come here, this 1 come here, this 1 come here. Okay. So it has now all 1 1 1. Now fifth state, okay, what will happen now? Q1 input is this is 1, so Q bar is input of Q1, so this becomes 0. So 0 comes here, okay, this is 1, this 1 comes here, this 1 comes here. Again, now this is 1, Q bar is 0, so this 0 comes here. So the 0 comes here, this 0 comes here, this 1 comes here, this 1 come here. Again for seventh, this is 0, this 0 comes here, this 0 comes here, this 0 comes here, this 1 here. And for eighth means again 0, so 0 comes here, this 0 comes here, this 0 comes here, this 0 comes here. And again, this all the things will repeat. Okay, so it has a total how many state? Okay, total 8 state. So 4 flip-flop, 8 state. Okay, so 4 flip-flop, 8 states. That's why this is called your mod 2n counter. So all your mod. So in an objective question, they can ask small questions like this. Okay, number of states they can ask. How many states are there in this type of flip-flops? Okay. So now you can draw the this state diagram also. So in the states, okay, so you have a state 0 0 0 0 in the beginning state, then you have 1 coming 1 0 0, then you have again third state is first state is your 0 0 0 0, second state is your 1 0 0 0, then you have 1 1 0 0, then you have 1 1 1 0. Okay, then you have 1 1 1 1, then you have 0 1 1 1, then 0 0 1 1, then 0 0 0 1, and then finally you have this one. Okay, so this is the diagram for 4-bit twisted ring counter. Now they can ask you to plot these pulses Q1 Q2 also with the clock. Okay, so that they can also ask you to plot. So if you want to plot the pulses, okay, so plot the pulses. How will you draw the pulse diagram? Plot the pulses with clock, each clock. So suppose I want to plot the Q1, Q2, Q3, Q4. Okay. So with each clock, and this is the negative triggering clock. So with each clock, we can find the pulse also, pulse diagram also, or waveform. So say this is my clock. Okay, so 1 2 3 4 5 6 7 8. Okay, so initially Q1 I told 0, so negative triggering clock. Okay, so if I want to draw for Q1, so initially Q is 0, so at first plus come Q1 becomes 1, and then okay, Q1 becomes 1. For second also it is 1, third is also 1, fourth is also 1, third 4 up to fourth is 1. Okay, as fifth comes it go downs. Okay, then it remains 0 0 0 0. So this is your waveform for this one. If you give ninth pulse now, okay, ninth pulse, this will become 1 0 0 0. If you go ninth pulse, this will transit to 1, and again this will repeat. Okay. Q2 is also 0 in the beginning. Okay, with Q2. Okay, so at second pulse it is getting 1. Second pulse it is getting 1. So it got 1 here. Okay, and then it becomes 6 pulse 0. At 6 is changing the state. So 6 is changing. Okay, okay, and if you go 10th, so this become 1 1 0 0. Okay, so only it will rise to 10th only. Okay, 9 after 10th only it will rise. So let me draw like this only. And similarly for Q3, start for 0, becomes 1 only for third pulse. So becomes 1 on third pulse and remains up to 7, changes again to 8 pulse. So 8 pulses come down and then it goes like this. And then we have a Q4. Q4 is becomes higher only for fourth clock, it becomes 1. Fourth clock, it becomes 1. So it's 1 shift, and then it becomes 1 up to 8 clock. 9th clock is come downs. 9th clock it come downs. No. 7th clock, 8th clock it's come down. Okay, 8th clock it come down. This is your 8th clock. Wait, this is your 1, 2, 3, 4, 5, 6, 7, 8. 8 and 7. So second Q3. Q3 comes where? Down 7th. Q3 comes for 7. Okay, Q3 comes for 7, down for 7. And this is come down for 8. So these are waveforms. Okay, so you can draw the pulse diagram. Similarly, you can draw the pulse diagram for your ring counter also. If the initial state is given, then you can draw the this pulse diagram for this ring counter also. Okay, so I'm giving one question. So I'm erasing this one. This is almost finished. Your counter finished. Then we'll do now conversion, D to A converter. Okay. Now we have 4-bit counter. 4-bit binary counter. Okay. Which is clocked. We have QA, QB, QC, QD. Okay. And I'm taking QB and QC. I'm using a NAND gate. I'm taking R bar from here. Okay. And this R bar is connected to asynchronous clear bar. Here we have a clear bar, and this just let me know. This is clear bar, and R bar goes here. So tell me, this is a mod, and so this says this is a mod and counter. Okay, this is the mod and counter. Okay, so what is the value of n? What is the value of n? You're asking what is the value of n? Okay, so how can we do? So when you know, so let me make a table for QA, QB, QC, QD. So we have QA, QB, QC, QD. Okay, so whenever this become clear bar becomes 0, whenever clear bar becomes 0, your clear becomes 1. Clear becomes 1. That means it will make the state 0, 0, 0. Okay, so this is my clock. Say this is my value of R. Okay, value of R and value of R bar. So R bar value should be 0. Then it will reset. Okay, so initial state says 0 0 0 0. Okay, now clock 1 is coming. Okay, so tell me how to do this one. So you have a 0 0 0 0 initially. Okay, now so
Sir, output at this given gate is R bar or R written
so
over
this
here.
is R bar.
Okay, sir. So
This is
then
R. This is R is your QB QC.
QB. Okay.
R is QB QC. Okay. So how to count this? How many states are there? How state will change? So say if I write 0 0 0. Okay. So for this R is 0, R bar is 1. So it will not start. Okay. 0 0 0 1. Okay. Still it is 0, it is 1. Okay. Second, if we say 0 0 1 0, I want QB QC. Okay. QB QC should become 1. So this is 0, again 1. Okay. 0 0 0 1 1 is again 0. You have 1. Fourth state, say fourth state is 0 1 0 0. So again this multiplication is 0, R 0, this is 1. Fifth state, if you say 0, now if I say this is 1 1 for 5, for 5 you should have 1 0 1. Again this is 0, this is 1. Okay, and if you go sixth, this is 0 1 1 1. Now this become 1, this become 1. Okay, now as it is 1 become 1s, it will reset everything. Okay, so as it's become 1, this will reset everything to 0. So this state will not come, so it becomes 0 0 0 0. Okay, so sixth state is 0 0 0 0. So you have total 6 state. 0 start 0 0, finish 0 0. So this you have only six state. So your n is equal to 6. Okay. Just give me 1 minute. Okay.
Sir, it is in notebook.
Sir, sir,
Sir,
voice नहीं आ रहा, sir.
शायद जा ही नहीं रहा है। हेलो,
Hello, sir.
शायद जा भी नहीं रही है। हेलो सर, आवाज नहीं आ रही। नहीं, नो सर, आवाज नहीं आ रही। So you have a ring counter, okay, which is loaded 1011 in the beginning. You have a QA, QB, QC, and QD, and this is your clock. Initially 00, you have 101011. Okay. Now this says plot the output waveform. Okay. So first you have 4 flip-flops. Okay. So obviously you will be having 4 states. Okay. So let us calculate the 4 state first. So clock 1, QD, Q1 output is this Q is 1. So 1 will come here. This 1 will come here. This 0 will come here. This 1 will come here. For second clock, this 1 will go here. This 1 will come here. This 1 will come here. This 0 will come here. For third pulse, this 0 is the output of this one. So this 0 will come here. This 1 will come here. This 1 will come here. This 1 will come here. And the fourth again, this 1 will come here. This 0 come here. This 1 come here. This 1 come here. So again 1001. So again repeating. Again it get repeats. So you have only 4 states. 4 different states for this ring counter because it has a ring counter, so it has only 4 things. Okay, and you need to make the clock also here, which is okay. So let it be, I say this is a negative triggering clock. So let me make the clocks now. So we have a clock. Say 1, 2, 3, 4, 5, 6, and I want to draw QA. So QA in the beginning it is 1. As first clock comes, it remains once, it becomes 0 only third clock. So this becomes 0 at third clock. Okay, and fourth clock again it becomes 1. Fourth clock has become 1. Okay, and fifth clock, what become? For fifth clock again, this become 1. This 1 he comes here. Okay, 0 1. Okay, I'm just writing. Seventh clock 1101 11 triple 1 triple 1 0. Okay, just you to see this QA change according to you to draw. So fourth it is getting 1, fifth it is getting 7, sixth also 1. Okay, so it's
Sir, it is sixth one. Fourth, fifth, and
sixth.
Sixth होगी ना?
Sixth. Okay. Okay. Now similarly for Q, बस आपको इसको देखना है. What is the QB was initially 0. Okay, and then it becomes 1 only at 1. 1 has become 1. This is 1, and then it remained 1 up to 4. 4 third and fourth is come down. So 4 it's coming down. So you can plot like this. And fourth is coming down, and fifth again getting up. Fifth, sixth are getting again up. So fifth, sixth one. Okay. Similarly, your QC in the beginning is 1. Okay. QC is 1, and become first it becomes 0. It becomes 0. Okay, and then it remains up to 1. 6. Third become again 1. So third again becomes 1, and it remains 1 up to fourth. Fifth come down. So fifth it's coming down. Okay, and sixth again getting up. So sixth is getting up. Okay, and QD. QD is initially 1. It becomes 0 at second pulse. So it goes 1, it becomes 0 at second pulse, and then it remains up to 5, and 6 coming down. So now this is 0 and third become 1, third again become 1 and remain like this 5 and 6 is comes down, 6 comes down. Okay. So this is QD is 1 in the beginning, QD 1 1 0. So 1 1 0 second comes 0, second comes 0. Okay, so these are the waveforms. So आसान क्वेश्चन आते हैं. Okay, एग्जाम में जो भी क्वेश्चन अब तक तुम्हारे जो तुम्हारा जो गेट फिजिक्स है, ओके, गेट फिजिक्स या नेट है, उसमें वो सिंपल क्वेश्चन तुम्हारे लिए तो वो सिंपल क्वेश्चन ही आते हैं. तो दिस टाइम इस बार भी जो क्वेश्चन आया है वो सिंपल क्वेश्चन ही आया था, गेट का क्वेश्चन आया था. एक स्टेप में, 2 स्टेप में क्वेश्चन हो गया था. So this is basically your end of counter. Okay, now tomorrow I'll start your this detail digital 2. So start here.
सर वॉइस को
एक मिनट. तो अभी डाउट है तो पूछो, कुछ डाउट है तो. कैमरा नॉट डिटेक्टेड.